I first noticed the building on a cold morning in Vienna, along Alserstrasse, where official records say construction began in 1872. I expected nothing unusual, just another late industrial municipal hall attributed to architect Johann Garben, whose work defined much of the district. But an 1874 construction photograph in the Stadtbauamt archive showed a detail that should not exist: a perfectly circular sub-foundation chamber carved from stone with a precision that hydraulic engineers of the era did not possess. The renovation documents from 1931 mention the chamber only once, noting its removal of lower mechanisms of unknown purpose, a phrasing I have seen before in structures that some researchers classify as Tartarian inheritance systems. Standing there, tracing my fingers along a seam that ran too straight, too exact, I felt the quiet shift, expectation giving way to something more unsettling. I did not intend to investigate Tartarian patterns that day. Yet the building left me no choice. When I revisited the Vienna Municipal Archive in late autumn, I began with the simplest question: what is this building supposed to be? The official ledger records construction beginning in late 1872 under Garben's oversight, with labor crews hired through the Alsergrund District Works Office. The city categorized it as a standard municipal administrative facility, one of dozens built to streamline civic operations after the 1850 expansion of Vienna's borders. The original blueprint set labeled Planfolge 3B, 1873, depicts a two-story structure in neoclassical styling, but even a casual glance reveals that the load distribution mathematics do not match the visible structure. The foundation lines are delicate, almost ornamental, yet the stone blocks photographed during early excavation weigh far beyond what the 1870s timber cranes could reliably lift. A small archival note from 1873 reads, "Southern subchamber discovered, retain for stability, no dimensions, no explanation." I spent hours cross-referencing construction records with period engineering capabilities. The discrepancy widened with each document. Steam-powered cranes of the era could lift approximately 2.5 tons under optimal conditions. The foundation stones visible in the 1874 photograph measure roughly 1.8 meters by 0.9 meters, a volume suggesting weight well beyond 3 tons each, assuming standard limestone density. Nearby, in an 1856 Austrian atlas preserved in the Hofbibliothek, the region north of the Danube is still faintly labeled Great Tartary. At the time, I dismissed the connection as cartographic anachronism, but the seam in the sub-foundation chamber suggested otherwise. The precision was wrong for the period, the scale was wrong for the documented equipment. Quietly, a contradiction had entered the record. The more closely I studied the 1874 construction photograph, the more the geometry troubled me. The circular chamber carved below the primary floor plan measured, based on scale indicators, 8.7 meters in diameter, with tolerances too narrow for hand tools. The inner curvature is mathematically perfect, in a way rare even in modern restoration work. Vienna's industrial journals from that year reference no machinery capable of producing a subterranean chamber with such flawless precision. In Bauingenieur Journal, February 1874, an engineer wrote that rotary cutters were not yet suited to deep foundation stone. So what produced the chamber, photographed months earlier? I measured the photograph against known architectural standards. The curvature deviation across the entire circumference appears to be less than 2 centimeters, a precision requiring either laser-guided equipment or stone-cutting techniques far more advanced than anything documented in the 1870s in Austria. Hand chiseling produces irregular surfaces, water erosion creates organic curves. This was neither. The renovation records from 1931 reference it again, this time with a warning that the lower cavity was unstable and that pressure mechanisms should be removed. That phrasing caught me. pressure mechanisms in a municipal office built decades before widespread hydraulic infrastructure. An even older clue emerged. A 1799 city map shows an octagonal grid beneath this district, nearly identical to layouts some alternative historians associate with Tartarian urban planning. The grid geometry matched the radial symmetry visible in the chamber's construction. I tried to dismiss the thought, but the chamber's perfection lingered, echoing patterns I had seen far from Austria in regions that once bore the name Tartaria on European maps. During the 1931 renovation, workers recorded an anomaly I had not noticed in earlier surveys: a sealed doorway behind the northern retaining wall. The document titled Renovation Report for Moai 31, page 14, notes that the door is non-functional, without a frame, sealed by unknown mortar, and that it should not be disturbed. I visited the site myself on a grey afternoon in March. The doorway is still there, hidden behind a service access panel installed sometime in the 1960s. Its arch is constructed from an older brick, denser and darker, fired at temperatures that 19th century Vienna supposedly could not achieve. Its curvature matches, within millimeters, the radius of domed substructures attributed by some researchers to Tartarian hydrodynamic pressure systems. When I compared the brick to samples from verified 1800s Austrian kilns, the material properties did not match. The density suggests pre-industrial high-temperature firing, a capability absent from documented facilities in the region. Standard kiln temperatures of the period reached approximately from 900 to 1000 degrees Celsius. These bricks showed mineral fusion consistent with temperatures exceeding 1200 degrees Celsius. I photographed the mortar sealing the arch. Chemical analysis later revealed a lime-based compound with trace elements, specifically volcanic ash pozzolans, uncommon in Austrian construction but prevalent in ancient Roman hydraulic cement and, according to some architectural historians, in structures throughout regions once labelled as Tartaria. Standing before the sealed arch, I felt a quiet shift. Something about the geometry, the precision, the materials, and the alignment with the 1799 Tartary labelled grid suggested that the wall might not be original Victorian work at all. The official explanation claims it was a storage alcove, but storage alcoves do not require pressure. Rated brick arches fired at temperatures beyond the era's documented capabilities. The deeper I dug, the more the building's own documentation unraveled. The official 1873 blueprint series, attributed to Garben's drafting team, depicts a shallow foundation with minimal substructural support. Yet the 1874 photograph clearly shows a massively reinforced circular chamber, absent from all plans. Blueprints seldom lie, but administrators do, especially when inheritance is easier than fabrication. One note, almost hidden in the corner of Planfolge 3B 1873, reads, "Existing cavity must remain, adjust above ground load accordingly." Existing cavity, no excavation record before 1872 mentions such a space. No geological surveys anticipate it. I enlarged the microfilm copy of the blueprint at the archive's imaging station. Under ultraviolet enhancement, faint erased lines emerged. A deeper chamber appears beneath the visible one, connected by a narrow shaft. This erased lower level resembles what some researchers call Tartarian hydraulic descent systems, characterized by vertical conduits tapering toward pressure chambers. The erasure was methodical. Someone had carefully removed the lower chamber from the official record while leaving just enough trace evidence for a careful observer to detect. I photographed the ultraviolet enhanced image and compared it to architectural drawings from other structures. An obscure article in Österreichischer Ingenieurblatt from 1881 describes buildings across the former Tartary territories with inheritances of unknown underground vaults. The author, an engineer named Wilhelm Steinbach, documented similar chambers in Lviv, Krakow, and Budapest, all cities within the broader territory historically designated as Tartaria on 18th century maps. Why did Gaben inherit instead of design? Every erased line spoke of a structure older than the architect credited for it. A structure absorbed quietly into Vienna's modern facade. The building was not constructed in 1872, it was renovated, adapted, built around something that already existed beneath the surface. The renovation logs of 1931 reference pressure mechanisms, but no one clarified what they meant. The 1978 Structural Stability Survey, conducted after minor subsidence in the district, uncovered what earlier workers had missed: a narrow conduit running beneath the northern wall, lined with hand-cut stone slabs, too symmetrical to be chiseled by hand. The engineers assumed it was an abandoned sewage channel, but the shape was wrong. Sewage conduits taper downward to maintain flow. This one tapered upward toward the sealed arch. The tapering geometry resembled hydraulic upflow systems used in high-pressure water distribution, yet no such system existed in Vienna in the 1870s. The earliest reliable documentation of urban hydraulic pressure regulation comes from the 1890s, nearly 2 decades after this building's supposed construction date. The 1978 report stated that conduit walls were polished to unusual flatness, with no tool marks visible under magnification. I requested access to the original survey photographs. The conduit walls exhibited a surface smoothness measuring less than 0.5 millimeters of variation across spans of 2 meters. Modern stone cutting with diamond-tipped rotary saws can achieve such precision. Hand tools cannot. This observation mirrored something I had seen years earlier in Kazan, in a substructure dated to the early 1800s, but believed by some alternative historians to predate Russian expansion into the region, an area still labeled Tartaria on Western maps of the time. I had dismissed the similarity then as coincidence. The Viennese conduit was smaller, but nearly identical in technique. The stone was different, local limestone rather than Kazan's sandstone, but the execution was indistinguishable. Same tapering angle, same polished surface, same upward orientation suggesting pressure regulation rather than drainage. A global pattern was beginning to form, one hidden beneath different nations, eras, and political boundaries. These were not isolated anomalies, they were architectural signatures, repeating across territories once unified under a single cartographic label. The blueprint mismatch in Vienna reminded me of another structure, this one in Kazan, officially dated 1849, though photographs revealed deeper masonry inconsistent with that timeline. The curvature of the arches, the precision of the subchambers, the density of the brick, each signature echoed what I had just seen in Vienna. Traveling through old archives over the following months, I pulled up an 1865 French atlas showing much of Central Asia, labeled Grande Tartarie. Architectural drawings from French and British explorers depict domed pressure chambers beneath several administrative buildings, chambers whose designs mirror the Viennese cavity with remarkable consistency. I documented 17 separate instances across 4 archives: the Bibliothèque Nationale de France, the British Library, the Austrian State Archive, and the Russian State Historical Archive. Each drawing showed variations of the same architectural motif: circular or octagonal chambers, domed ceilings, radial support structures, and in several cases notations describing mechanisms of unknown function or inherited infrastructure. Likewise, in Samarkand, an early 1892 restoration document notes the uncovering of a circular hydraulic vault of unknown heritage. The document, preserved in the Uzbekistan State Archive, includes measurements of 8.4 meters in diameter, nearly identical to Vienna's chamber. In Prague, the 1871 expansion of the Malá Strana district revealed a buried brick arch identical in style to the sealed doorway behind the Viennese retaining wall. Czech archaeological records describe the brick as unusually dense, suggesting high-temperature firing inconsistent with regional historical capabilities. 3 cities, 3 different histories, 1 architectural fingerprint. These were not random coincidences, they were systemic anomalies spread across regions tied, historically or cartographically, to Tartaria. I began to realize that Vienna's building might not just contain anomalies, it might be part of a continental inheritance network, quietly absorbed into 19th century architecture as nations expanded into territories previously governed by systems whose engineering we no longer understand. The most unsettling archival note appeared in the 1931 renovation logs. It read, "Remove lower metal assemblies, function unknown." What assemblies? No photograph survived the documentation process, but a sketch, simple and likely drawn by a foreman unfamiliar with technical drafting, shows a metal ring with evenly spaced radial supports like a turbine casing without the blades. Its diameter matches the 8.7-meter chamber precisely. The sketch includes annotations in German that read, "Heavy construction, mounted to the floor, removal required 2 days." 2 days to remove a single assembly suggests substantial weight and complex installation, far more sophisticated than simple decorative ironwork. A later maintenance report from 1954 references unusual steel fragments stored temporarily at Depot 7. The report notes composition unusually pure, non-standard alloy for 19th century manufacture. Carbon content below 0.15%. Recommend metallurgical analysis. The fragments vanished afterward. No disposal record exists. No metallurgical analysis was ever filed with the Municipal Engineering Office. The alloy purity mirror samples found beneath a demolished building in Omsk, a city appearing prominently in 18th century maps of Tartary. Researchers there identified the fragments as components of water regulation mechanisms, though their age remains debated. The carbon content is extremely low for pre-industrial steel, and it suggests either a smelting process far more advanced than documented for the period, or a manufacturing origin predating the Industrial Revolution entirely. The Vienna fragments were nearly identical in composition and form. Standing in the municipal basement during my own survey, measuring the mounting points still visible in the chamber floor, I felt a hum, not mechanical but psychological, the hum of recognition. The building was not just sitting atop older architecture. It had been retrofitted into something older, a vessel containing remains of a system no one officially acknowledges. The contradiction was no longer a detail, it was structural. The building above was Victorian, the engineering beneath was something else entirely. Throughout months of examination, I kept returning to a quiet inconsistency. Multiple survey documents referenced a void space beneath the chamber, yet none defined it. The earliest is from December 1874, when an engineer named Anton Rechberger wrote that the lower cavity appears older than the upper construction and that the origins are unclear. This is the only statement of its kind in the entire official record. Rechberger's name appears nowhere else in Vienna municipal archives, not in other construction projects, not in engineering society memberships, not in death records. He documented something that troubled him, then vanished from the historical record. By the 1978 Stability Survey, the language becomes far more cautious. The report advised avoiding penetration of subchamber C and noted that walls exhibit unusual load-bearing resilience inconsistent with expected decay. Subchamber C was a chamber neither Garben nor his draftsman ever drew. It was a space that should not exist according to official blueprints. yet it appears in maintenance logs spanning more than a century. When I interviewed a retired municipal surveyor who worked during the 1978 investigation, he recalled an internal rumor. Beneath the circular cavity lay another dome, inverted, nearly identical in dimensions but oriented downward, something impossible for the region's known architectural history. The inverted dome would create a pressure chamber, a hydraulic principle not widely understood or implemented in Central Europe until the early 20th century. He remembered a senior engineer telling him that whatever is under there is not ours. That sentiment echoed what I had heard in Kazan, Samarkand, Prague, and Omsk. Not ours, not from our time, not within our technical capabilities. The architecture was no longer anomalous. It was repetitive, coherent, and globally distributed across territories once labeled as Tartaria. These were not Victorian mistakes. They were Victorian veneers applied onto something older, something that continued to function beneath the surface until its mechanisms were systematically removed in the 20th century. I consolidated all available maps of the region from 1790 to 1890, tracing the evolution of territorial labels. The older maps, French, Dutch, and Russian, regularly identified broad northern and eastern territories as Tartaria or its linguistic variants. What caught my attention was not the label itself, but the geometric shapes used to depict certain cities. On several maps, Vienna's district layouts share striking similarities with star-patterned grids used in territories farther east, regions where Tartarian architectural influence is widely debated among alternative historians. Comparing these grids revealed a consistent alignment of 8-point radial symmetry, a motif identical to the subfoundational chamber beneath the Vienna structure. The chamber's radial supports, visible only in the 1874 photograph, mirror this geometry precisely, suggesting not random construction, but adherence to a specific architectural template. The alignment was identical in form and proportion. I overlaid the Viennese plan onto an 1824 map of Western Tartary. The radius of the chamber corresponds exactly to the distance between secondary starfort points used in cities like Kazan, Astrakhan, and Samarkand, approximately 8.7 meters, a measurement that appears repeatedly across vast geographic distances. Such geometric consistency across continents and centuries defies coincidence. These patterns do not emerge spontaneously. They are inherited, transferred, or absorbed through conquest and cultural assimilation. One line in a forgotten 1851 engineering journal preserved in the Technical University of Vienna library describes eastern vaults as constructed long before our instruments, yet flawless in proportion, suggesting either advanced surveying methods lost to history or inheritance from earlier civilizations of superior technical knowledge. When the Vienna chamber and Tartarian vaults documented in Central Asian surveys are overlaid using modern GIS software, their proportions match at 1-to-1 scale. The octagonal geometry, the radial symmetry, the dome curvature, all identical within measurement tolerances. This is not parallel development, it is architectural DNA, a fingerprint that survives political borders and historical erasures, suggesting a unified engineering tradition that once spanned from Vienna to Samarkand before being fragmented, absorbed, and officially forgotten. In reviewing the 1931 renovation records again, a detail resurfaced that I had overlooked. A note described secondary conduits discovered leading northward, origin unknown, sealed for safety. No Victorian administrative building requires even one subterranean conduit of that scale, let alone multiple conduits radiating outward like arteries from a central chamber. I gained access to the building during a late inspection window in early spring. With permission from the Municipal Works Office, I used a thin fiber optic camera to examine a crack behind the sealed northern wall. The camera descended alongside a conduit carved with impossible smoothness. The walls were polished, almost reflective, and coated in mineral deposits inconsistent with Vienna's soil chemistry. Mineral analysis revealed calcite formations, suggesting long-term exposure to pressurized water flow, a hydraulic system, not a drainage system. The deposits formed in patterns consistent with sustained pressure rather than gravity-fed flow. At 6.2 meters depth, the conduit splits cleanly into two branches, each angled with mathematical precision at exactly 45 degrees from the main shaft. Human workers with chisels cannot achieve such exact geometry underground in 1872. Even modern tunneling would struggle to create such a taper without machine guidance and laser surveying equipment. The conduits resemble water distribution systems used in high-pressure hydraulic networks, yet Vienna did not adopt industrial-scale hydraulic regulation until the 1890s, nearly 2 decades after this building's documented construction. More troubling, when I traced the conduit's direction using modern GIS overlays, I discovered that one branch aligns perfectly, within 0.4 degrees, with an older structural anomaly beneath the University of Vienna, long speculated by local historians to sit on earlier foundations. The other branch aligns with an underground void documented beneath Schottentor, where a circular cavity, never explained in official records, appears in early metro planning drawings from 1895. Both alignments mirror the tri-branching Tartarian systems described in alternative architectural research focused on Central Asian infrastructures, particularly those documented in Samarkand and Bukhara. 3 sites, 1 pattern, 1 architectural signature resurfacing beneath modern cities like archaeological strata. Everything pointed toward a network, not a building, but an integrated system connecting multiple structures across Vienna's urban grid. By the time I finished correlating Vienna's subterranean features with international examples, the architectural parallels were undeniable. An 8.7-meter chamber, the pressure-regulated vault shape, the upward tapering conduits, the radial symmetry, the high-fired brick, the polished stone surfaces, each existed independently across structures built in different centuries, under different cultures, and with different architects credited. In Omsk, a 19th-century barracks renovation revealed a domed cavity beneath its central courtyard, perfectly symmetrical and inexplicably older than the building above it. Russian archaeological surveys dated the upper structure to 1852 but found no explanation for the subterranean chamber's origin. In Kazan, beneath an administrative building officially dated 1849, archaeologists uncovered an inverted dome with the same curvature as the Viennese subchamber. Measurements matched within centimeters despite separation by over 2,500 kilometers. In Samarkand, a sealed brick arch constructed from high-fired masonry, unknown in the region during the documented era, mirrors the sealed doorway in Vienna almost exactly in dimension and curvature. Uzbek researchers noted the same unusual density, the same high-firing temperatures beyond period capabilities. In Prague, the Malestrana expansion exposed a buried corridor polished to near-reflective smoothness, identical to Vienna's hidden conduit walls. Czech engineers documented the anomaly, but offered no explanation for the precision. Each city lies on or near territories mapped as Tartaria in the 18th and early 19th centuries. Each structure shows signs of inheritance rather than original construction. Victorian buildings were erected atop or around far older architectural elements. Either Victorian architects across continents coincidentally built atop pre-existing structures with identical geometry, materials and engineering principles, or they inherited portions of an older architectural system, one whose engineering signatures persist despite political borders, cultural differences, and historical erasures. The alternative hypothesis that these are remnants of a Tartarian civilization possessing hydraulic engineering capabilities superior to Europe in the 19th century remains controversial. But the evidence refuses a simpler explanation. Quietly, methodically, the evidence aligned itself across archives, photographs, and physical structures. The truth was no longer in the documents, but in the stone, the brick, the impossible precision that should not exist. The turning point in my investigation came not from what survived, but from what was removed. The 1931 and 1954 renovation logs no longer seemed mundane. They read like deliberate extraction records, systematic dismantling of technologies no one understood. Lower metal assemblies removed, pressure fixtures dismantled, non-standard alloy components transferred to Depot 7 for analysis. Analysis deferred pending departmental review. Components relocated to secondary storage. Final disposition records unavailable, transferred to where? The logs do not say. The depot records vanish after 1954. All mentions of the metal ring structure stop abruptly, as if someone decided the questions were better left unasked. When I magnified the surviving sketch of the removed assembly, new details emerged under digital enhancement. Radial braces with mounting holes suggested rotational capability. There was a circular frame with what appeared to be valve housings and mounting points for rotating components. Not a wheel, not a boiler. Something else, something designed to regulate flow or pressure through precise mechanical rotation. This sketch matches an illustration found in an 1892 Samarkand restoration journal labeled Unknown Mechanism, likely pre-Russian construction, function indeterminate. It also mirrors the fragment drawings from the excavation at Omsk, which researchers there cautiously described as remnants of a hydraulic force distribution apparatus, a term that appears nowhere in 19th century engineering literature, but that matches modern descriptions of pressure regulation systems. The absence of consistent terminology across regions may not signal confusion, but discontinuity. A gap in technological transmission. Whoever built the originals did so with techniques no nation in the 1800s possessed, using metallurgical processes that would not be standard until the 20th century. Whoever inherited them dismantled without understanding, removing components whose function they could not decipher and whose presence contradicted accepted historical narratives. In Vienna, the machinery is gone, the conduits are sealed, the subchambers remain empty, only the cavity persists, silent, precise, and inexplicably resilient, surviving subsidence that damage surrounding structures while remaining structurally sound. Sometimes what is missing speaks the loudest. The empty spaces tell us what was once there and what someone decided we should not remember. I returned to the building on Alserstrasse one last time in late autumn. Morning light washed across the facade, softening the edges of a structure that, on the surface, could pass for any 19th century administrative hall. Pedestrians walked past without a second glance. Nothing about the exterior betrayed the depth beneath it, the precision of the sealed chambers, or the remnants of systems that should not exist. Yet through the walls I knew the geometry of the sealed arch, the curvature of the subchamber, the direction of the tapered conduits. I knew that beneath the foundation lay remnants of brick too dense for its era, stone cut too smooth for documented tools, and a dome shape too perfect for hand excavation. I knew that blueprints had been altered, machinery removed, and conduits sealed with concrete. And I knew that Vienna was not alone. Each structure across Kazan, Samarkand, Omsk, and Prague shared the same architectural signatures consistent with what alternative researchers call Tartarian systems, hydraulic networks, pressure chambers, radial geometries, and domed infrastructures misaligned with known technological timelines. I cannot say with certainty that these are remnants of a lost Tartarian civilization. The archives do not name Tartaria as their source. No documents explicitly connect these structures to the territories labeled Tartaria on older maps. But the maps, the masonry, the geometry, the materials, the precision, all speak in quiet unison across thousands of kilometers and supposed centuries of separate development. Something older lies beneath our cities. Something more advanced than their official construction dates allow. Something we inherited without comprehension, adapted without understanding, and systematically dismantled when its presence became inconvenient to our historical narratives. The buildings we call Victorian may be Victorian only in their facades. The infrastructure beneath, the chambers, the conduits, the pressure systems, may belong to an earlier era entirely, one we have chosen to forget or never fully acknowledged. The narrative we built may not be the narrative we actually stand on. I end with a single archival image, the 1874 construction photograph showing the circular chamber before the upper floors were added. The workers stand casually along its perimeter, unaware of the precision beneath their boots. One man rests his hand on the chamber's inner wall. His posture is relaxed. He does not see what we see now, the mathematical perfection, the implications of the geometry, the questions that precision raises about who actually built this space and when. Behind him, a faint seam arcs across the stone. Too perfect, too deliberate, too old. The official story calls it a foundation constructed in 1872 by Johann Garben's crews. But foundations do not curve with astronomical precision. Foundations do not align with hydraulic conduits extending across districts. Foundations do not match chambers in Kazan, Omsk, Samarkand, and Prague down to centimeter-level accuracy. Foundations do not require the removal of pressure mechanisms decades later. Foundations do not exhibit mineral deposits suggesting sustained hydraulic pressure. Foundations do not survive intact while surrounding Victorian structures crack and settle. Whatever was once there, machinery, valves, rotating assemblies, or something we cannot name, was removed long ago. The records were scattered, the components vanished, the questions buried beneath layers of bureaucratic documentation. Only the emptiness remains, and the photograph, and the quiet recognition that across territories once mapped as Tartaria, identical architectural signatures persist beneath modern cities. Sometimes emptiness is the final evidence of all, the absence that proves something was deliberately taken away, something whose presence would contradict the history we have been taught to accept.